questions in the homework sets. You will see one other thing that we have to talk about here. Determine the number of standard deviations of a weight of 80.5. How far that is from a mean weight of 76 kilograms if the standard deviation is 3 kilograms. Options for you. Pictures. Where's the center of your universe on this problem? 76. What's the standard size step for this problem? Where do you have to be at the end of this problem? And 80.5 is where in relationship to the 76? To the right. So out here somewhere is your 80.5. That is a total of 4.5 units. One full step takes you to 79. And now you need another full step or a part of the step?
Part of the step.
So if I'm at 79 to 80.5 is 1.5 units. And 1.5 out of 3 is 0.5 units. A half a step. So you moved one full step, one full plus 1/2 means that you're at 1.5. Now there's the pure picture way of doing it. Here's the short way. Your total distance you need to cover is 4.5 units. 4.5 is a parts of 3 standard step size. So 4.5 divided by 3, same 1.5. Pieces and parts are all at once. When you find the distance in here, you're going to be doing a subtraction problem. And then you're going to be doing a division problem. It can be that simple. Or you can do repetitive subtraction, repetitive addition, or repetitive subtraction. Determine the temperature of a freezer that's 2.5 standard deviations colder than a group of freezers that are normally distributed with a mean temperature of 15 and a standard deviation of 1.4. So if I'm a picture-oriented person, my universe is centered at 15. And I know that my standard size steps are 1.4. And I want to have something that's colder, so its temperature is to the right of 15 degrees or to the left of 15 degrees? Better be the left. So somewhere over here is where I want to be. And I know that that wants to be 2.5 standard deviations. So one step of 1.4 takes me to 13.6. A second step of 1.4 takes me to 12.2. And now I have to have a half of step, which is a 0.7. So now I take my half step out there, which will take me to 11.5. Because I'm going to subtract that 0.7 from the 12.2. Or I come back here and I say, from 15, I need 2.5 standard deviations to the left, because that's the one that's colder. So 15 minus 2.5 increments of 1.4, calculator based. 15 minus that 2.5 increments of 1.4 takes me to exactly the same 11.5. You have choices. Doesn't make a difference. Similar type of problem? I'm not drawing pictures now. Where do I know the center of my distribution is? What do I know the standard deviation is? 6. Where do I need to be?
1.5
Within 1.5 standard deviations. So I need to know not only this value, but I also need to know that value, don't I? So this is a 2 for the price of 1. 150 plus 1.5 groups of 6. 150 minus 1.5 groups of 6. Well, 1.5 times 6 is 9, so I know that this is going to take me to 141, and I know that this is going to take me to 159. So there are my interval values between 141 and 159. I will be within 1.5 standard deviations. We don't have an area for that because it takes calculus to do that unless it's exactly 1, exactly 2, exactly 3. What percent of July temperatures in New Orleans will be less than 91.6? Okay, we want to do a little bit of a picture for this one, okay? And then we're going to look at the second piece on that graphic, the second one, to be able to give you a little bit more information. Center of my universe on this particular problem is 91.6. I'm not doing that. I'm trying to get rid of these because I didn't disable the draw line feature. I know this is where 94 is. Where's 91.6? It's back here somewhere, isn't it? Do I know exactly where? Can I start figuring out? So since I know that standard deviation is 2.4, if I took 94 and I subtracted 2.4, lo and behold, that gives me a 91.6. So how many steps did I take backwards? 1 step. So this is 1 standard deviation, but I don't have a measurement for pieces of that 68, 95, 99.7 yet. Well, guess what? We're going to get it real quick. So I'm going to put a blank page in here. I didn't want